We do everything to make our homes comfortable. We decorate, furnish, renovate, and we heat them to keep ourselves warm when it's cold outside. Since each home is different, the heating needs of each home are different. So how can you choose the best heating system for a home?
Whether you want to heat a house from top to bottom or just warm up a cold room, electric heating units are a simple, comfortable, easy to install, and above all, economical solution. But are they equally effective in terms of comfort and energy savings? That's an important question. A recent survey shows that the majority of your customers are not completely satisfied with the level of comfort of their homes. They make up a significant market potential, and ConvectAir is the best heating solution for consistent comfort. Let's see why. We're in ConvectAir's research laboratories. This is where we compare and measure different heating systems under real conditions. A refrigeration system recreates the outside winter environment, and particles in the air allow us to see how heat circulates in the room. Right now it's 30 degrees Fahrenheit outside. Notice the current of cold air moving down the wall. Heat loss is occurring, and as the air cools, it becomes heavier. Let's turn on the baseboard heater. The air just above the heater starts to move, and a column of hot air shoots up the wall. As it reaches the top, the heat forms a turbulent layer that stays within a foot of the ceiling. We can leave the heater on, but the air circulation will not improve.
The result? The heat climbs up the exterior wall and accumulates below the ceiling. There's no air moving anywhere else in the room. The heat is poorly distributed. In other words, the room is uncomfortable and a lot of energy escapes through the cold wall and ceiling.
To see where the heat goes, we'll use an infrared camera hooked up to a computer. This will give us a better idea of temperature variations. Red areas are warm, blue and black areas are cold. Let's turn on the baseboard heater. The heated air leaves the unit and begins to climb the wall. Looking straight at the wall, we can clearly see warm areas. Look at that. All these areas represent hot spots with high heat loss. In other words, wasted money and energy that's leaking out of your home instead of making you more comfortable.
Since the air must circulate to heat the room evenly, we'll install a fan-forced heater of the same wattage as the baseboard heater.
Let's turn it on. Amazing! Look at the blasts of hot air traveling across the room at floor level. It goes as far as the cold wall and then rises up to the ceiling. But notice that the air in the middle of the room isn't moving. So the heat is still not being evenly distributed.
The results are no better than they were for the baseboard heater. The heat collects at the ceiling. There's major heat loss along the exterior wall. The fan is noisy, and you still aren't comfortable.
Now, let's see what happens with a natural convection ConvectAir heater with the same wattage as the baseboard and the fan-forced heater. Let's turn the unit on. Notice the hot air coming from the ConvectAir grill. It flows towards the middle of the room, not against the wall. Take a closer look. There's no heat against the wall, so there's no wasted energy. Look at the center of the room. See how the particles, which remain motionless with the other units, are now moving slowly to the left. They're being pulled by the column of hot air. This constant movement distributes the heat evenly throughout the entire room. The heat does not accumulate at the ceiling, and the circulating air eliminates the cold at floor level.
The result? Less heat loss, more even heat, greater comfort, less money and energy wasted. And this is exactly what your customers are looking for.
Heat always wants to move from a hot area to a colder one. So the greater the difference between the temperature inside the house and the temperature outside, the more heat will escape. This difference in temperature is called delta T. The purpose of heating is to compensate for the heat that escapes. Look at an example. It's 70 degrees inside the house and 50 degrees outside. The delta T is 20. Now, if it's 70 degrees inside the house and 30 degrees outside, the delta T is 40. So there will be twice as much heat loss, and we'll need to produce twice as much heat to maintain the same level of comfort. Now, let's examine the wall using our infrared camera. We'll draw a square on the wall and measure the temperatures. As you can see, the delta T obtained with ConvectAir is 27% lower than the delta T obtained with the baseboard heater. In other words, you need 27% less heat to compensate for heat loss from this surface.
You may be wondering what this number would be for the whole room or the whole house during an entire heating season.
By using other instruments, we can simulate how a ConvectAir would affect the house during a heating season. We can also calculate how much energy is saved.
The results are significant. The ConvectAir Natural Convection Heater with built-in electronic thermostat produces savings of up to 30%.
That's the ConvectAir difference. And remember, only a ConvectAir carries the ConvectAir name.
ConvectAir. Heat that makes sense.